Hello everyone, today we're going to talk about completing the treadmill, slide, health units, and phone mission. Just like my other attachments, this one looks complex, but is just made up of a few simple mechanisms. Let's start with the slide mission. My robot completes the slide in two parts. The first is this basket. At the beginning of the run, the robot pushes the basket to the slide. At the front of the basket, there are these two angle pieces for mechanical alignment. If the robot's angle is a little bit off, the angles on these beams guide the basket into the right place. Since the robot is not connected to the basket, after the robot pushes it to the right place, it can just leave the basket there. The second part is this passive mechanism, which is basically an angle beam connected to a hinge. Watch closely. First, the robot lines up so that the angle beam is behind the second figure. As the robot moves forward, the incline of the slide pushes the angle beam up, so that the angle beam pushes both of the figures off of the slide. The figures fall into the basket, which is pulled back to base in the next run. Sometimes in FLL, missions are completed best in two separate parts. Here, it's much easier to push the figures off the slide and capture the figures in two parts than just one. Now let's talk about a concept that is really important, using one motor to control multiple mechanisms. Using this technique allows you to complete more missions in one run. On my attachment, one motor is used for the wheel for the treadmill mission. The other motor powers two mechanisms at once, one for the row machine and one for the health units and phone. The first rack and pinion is at the front and is used for the rowing machine. The two claws on the rack and pinion hook into the wheel to pull it. The second rack and pinion is at the back and is used to collect the phone and the health units. This rack and pinion powers a portcullis, which is a door found on castles and is also known as a vertically moving door. The portcullis is used to capture the health units and the phone. So how do you power two mechanisms using one motor? It's really simple, but there's a catch. The basic idea is that you have to use gears to connect both mechanisms to the motor. On my attachment, you can see that the gear train starts with this 20-tooth gear, which is connected to a gear on the robot. This 20-tooth gear is connected to this axle right here. Let's call it the main axle. From this main axle, you can see that there are two more gear trains that come off of it. First, here at the top, knob gears make 90-degree connections so that the front rack and pinion is connected to the main axle. Second, here in the middle, 90-degree connections connect the main axle with the secondary axle, which extends to the back of the robot. This secondary axle is connected to the gears that power the rack and pinion at the back of the robot. Watch how the gear connections on my attachment transfer energy from the robot to the main axle to the two mechanisms. Now here's the catch. We have to make sure that one mechanism won't break the other. Let's take a look at this example. Both of these rack and pinion mechanisms are powered by the same axle. Since the smaller rack and pinion is shorter, it cannot be moved as far as the larger rack and pinion. And as you can see, when I turn the axle, since the smaller rack and pinion cannot be moved as far, only part of the larger rack and pinion can be moved. The smaller rack and pinion has broken the larger rack and pinion. For this to work, our rack and pinions need to be about the same length. Since the best way to learn about mechanisms is to build them, I have linked instructions for these models below. The model about controlling two mechanisms at once is not the same one on my attachment, since I have taught rack and pinions in the past. This one is much more helpful in my opinion, since it shows how to gear two mechanisms to one motor. I hope this video helped your team out. If you enjoyed it, please hit like and subscribe for more tutorials coming out in the future about completing FLL replay missions.